life more difficult when you program?
Would be better like if it was like a triangle star.
Hmm?
If it was like triangle star. Like
If we have another,
like
a few
for
other
that
classes.
example, if the star is inheriting from that triangle, like the properties on the triangle. So it's similar.
okay, then it is a star triangle. Is it?
Made up of triangles.
Yeah, it's made up of triangles, so you can declare them sort of in a composition, composite relationship, but not inheritance. Because other than having some sort of very small common, they don't really. All the behaviors are different. To calculate the area of a star, it's very complicated, and the way that you calculate the area of a star is completely different from calculating the area of a rectangle. So if you make this one the right class of this, and you declare an area here, then you would definitely have to override area in star, and not just area, but circumference. Is it circumference? And I don't know, and other properties of a triangle that the star doesn't have. And keep in mind that even when you override something, it's not like you actually get rid of it. It would just be hidden away in memory forever. So you always carry around two copies of the same function, and it's actually not optimized. So even in terms of coding, this is not a good idea to make a star.
When would that be a good?
When would it be a good idea? If you can substitute the base class with the drive class. So let's say you can live in a building, right? So it could be a house, could be an office, could be a public toilet. It doesn't matter. But if you substitute the word house or office or public toilet with building, does the sentence still make sense? If it does, that's a good idea to make them inherit each other, because that signifies that a house is a building, a public toilet is a building, and an office is a building. So yeah, it's all sort of go down to semantic. These examples are very clear, but there are true sort of difficult examples that you sort of don't know what to do. If I can find one of those examples, I'll show you. But in this example, it's very obvious that shape is not a point, so it doesn't make sense to do this semantically. Whereas in here, it is obviously true that a square is a rectangle. Everything that you can do with a square, you can do with a rectangle. So if you substitute square with rectangle, can a flat be square or rectangle? I have if you have a square flat, you do have a rectangle flat, except that the two width and height are the same. But if you substitute those two terms, they still make sense. The sentence still makes sense. So in this example, because shape is not a point, but shape is made up of multiple points. So first, shape is not made up of one point. It's made up of multiple points. So it makes even more sense to instead of having one instance of point, you can have an array of points, for example. And you have a very nice composition relationship between shape and position and point. Yeah, so this kind of semantic will help you to decide whether class A should have a class B as a component, or should it inherit from class B. So shape is not a kind of point, but shape has a point. Position composition makes more sense. Any question? No? Yeah. Fortunately, this lecture is just filled with concepts. We probably will come to some coding next time. Or it will make more sense. It will be easier to understand. So, in summary, when you declare class A child of class B, you inherit everything in class B into class A, even the private. However, the scope of the variables can change, and that depends on how you inherit, public or protected or private, and also how you declare the original scope of the variables in the base class. And second, when you inherit something and you want to change one specific behavior, then you can redeclare the function, which is called overriding. But if the behaviors in the derived class and in the base class is the same, don't do it. That's all. Right, so let me write it down. Have 5 minutes. Okay. Derived class inherit from base class. Everything in B goes to D. That's the first point. Second point is, but the scope might change. And it changes in this way. It is a minimum accessibility between the original modifier and this up. And the inheritance. You can see it, can you?
I was wondering if you were to inherit a private B, and then you would try to inherit something from D, you still get stuff from B.
When you inherit a private from B, can you say that again?
So say you were to inherit, D would inherit a private B, and then say, for example, A would inherit everything from B. Would A still have access to B's stuff?
Not directly. So as I said, everything in B goes to D, even the private, except that you can't just access those private variables directly. You can call some function.
So you could use get as success. So you could use get as success.
Sorry?
So you could use get as success, for example.
I can use what? Sorry?
Get and the set.
Huh?
Get and the set function.
Yeah, get and set. Right. So if B declares a variable x to be private, you can access directly from D. But if B provides a get x and get y, get x and get and set x public function, then you can call those from D and change the variable, which doesn't really belong to D. But you can still do it. So that's why keep in mind everything in D goes to D, even the private. Are we running out of time? I guess these two are the most important thing that you can get out of today's lecture. Anything else, you can read it from the slide. Everything in B goes to D, even the private. And the scope changes by minimizing the accessibility of the original modifier and the inherited modifier. Alright, so that's it for today. I'll see you tomorrow.
Do you have office hours and
Oh yeah. You can send me email. I'm not sure if I'll be in my office. This is MS 106 in the mathematical building. email. Yeah. Keep in mind that I can't make all decisions. Something I might have to wait for Lena to come back. But if I can, I will answer.